So this question says that there are voltage across resistor, voltage across capacitor, and the power source is 80V, right? So we can do this. Set up equation first. So we know that there's a VR, voltage across resistor, and then also voltage across the capacitor. Add together is 80. So VR is actually R times I. VC is actually Q over C. Okay. Now this equation is correct, but I want to get a differential equation so that I can solve. So you have to know that I is what now? I is dq dt. So you turn the equation to R times dq dt plus Q over C 80. So this is become a differential equation. Then put in R here. R is 250. And then C here. C is actually 2 microfarad. This is 2 times 10 power minus 6. Okay, 2 times 10 power minus 6 here. And this one actually 80. So now we divide everything by 250 to get a central equation. So here's the calculator. Okay, what is that now? Okay, 250 times 2 is 500, right? So this is actually 1 over 500 times 10 power minus 6 microfarad up, so minus 6 here. So you get 2000, okay? So this become dq dt plus 2000 q 80 over 280. So 80 over 280 is 8 over okay, 16 over 5, okay? Anyway, okay, 80 over 250. So we get 8 over 25 here. This is the first order differential equation. So we're going to solve this differential equation now. Okay, our normal equation is actually dy dx plus px and y equal to qx. But we don't have y now. Y is q now. Your x is t now. Okay, t here. This t here. Your x is t now. So this is t here. So you compare 2000 is your p, and then 8 over 85 is your q. And so you can write on the next page there. PT is 2000. QT 8 over 25. So you can find mu t now. Mu t is e power pt dt is e power 2000 dt. So you get 2000 dt integrate like e power 2000 t unique plus c. Make this here. So finally, you can write the solution now. Solution usually I use is a y mu x here, mu x times y here. Okay, equal to mu x qx dx here. The only thing you don't have Y is actually your Q now. You don't have mu x here, you have mu t now, which is e power 2000 t. Okay, so you put it in. Right, then you integrate. So this integrate e power 2000 t and qt now. Qt is 8/25 dt. So this is actually e power 2000 t q integrate 8/25, take out first, then get e power 2000 t over 2000 plus c. Okay, get all the big number come in. So we're going to find out what is c now. But we're given that the capacitor has no charge at the beginning. And t equals 0, q equals 0. Okay, and the question says that capacitor has no charge. Okay, initially discharged. I mean, there is no charge in the capacitor. Initially discharged. No charge in the capacitor. So we can use this information, okay, to find that means that this is 0 now. This is 8/25 times 2000 when t equals 0 and plus c. So what is this equal to? So 8 divided by 25. Okay, let me see. So 8 divided by 25 times 2000. Okay, 6250. So C equal to minus 6250. Okay, got a C already. C equal to minus 1/6250. So I can rewrite the formula for Q now. So next page here. So I have e power 2000 t times Q equal to 1/6250 times e power 2000 t minus 1/6250, which is my C here, right? So look at this one. So everything, okay, 8/25 times 2000 is 1/6250. So now you can divide by e power 2000, you get 1/6250 minus 6250 over e power 2000 t. So this is actually Q 1/6250 1 minus 1000 t. So this is a charge of in the system. This is what charge at any time, right? Do they actually want the charge at any time? I don't think so, right? They want the current. Okay, they want the current. So this is how to find the carbon now. We're going to find the question is about carbon here. Okay, the one is how long is switch is closed and when the capacitor voltage is 36 or 76. Okay, and how do you find? Let's try to find a current first. Okay, I got this already. The current I is dq dt. So when you do this, you get 1 over 6250. Differentiate 1 and get 0. Differentiate the other one is minus 2000 e minus 2000 t. Okay, so based on this, let's see how much that 2000 over 6250 get 8 over 25. So this is 8 over 25 e minus 2000 t. This is current at any time. So I know the current at any time already. Let's try to draw a circuit again. The circuit has two components and a power source. So insert there. Circuit has two components. One of them is a resistor. The other one is a capacitor. The power source is 80 volt. Right? Power source is 80 volt here. Based on this. Okay, 80 volt here. So I copy again. So this one is for this question. Okay, so 250 and 2 microfarad here. Okay, 250 and 2 microfarad. So this 250 here and 2 microfarad here. So they tell you that the voltage across a capacitor is 76 volt. Therefore, the voltage across the resistor must be equal to 4 volt, right? Okay. So what is the voltage across the resistor? Because the VR equal to Ri. And now the voltage across resistor is 4. So I is what now? 4 over R, which is 4 over 250. So you press the calculator. 4 over 250, you get 0.016. Okay, amperes. Okay, 0.016 ampere is actually 16 milliampere, as given in the answer. So answer is 16 milliampere, right? What's the answer? Yep. Then, so this answer, what is the voltage? What is the current? The current is 60 milliampere. Okay. How about time? At that time, how long it take for this capacitor to charge to 76, right? It's the same thing as how is it to become a resistor, okay? So you find out that I, okay, we're going to, since I, we had earlier calculated, okay, is 8 over 25, okay, E minus 2000, okay, 8 over 25, E, okay, I want it to be 16 ampere, right? So it's 0.016, okay, because at that time, the current is 0.016, so you can get 0.016, okay, 0.016 here is actually 8 over 25 e power minus 2000 t. So that means that you can multiply by 25 times 0, okay, so multiply by 25 and divide by 8, you want 20, right? So get 1 over 20 equal to e power minus 2000t. So 1 ln of 1 over 20 divided by minus over 2000 you got t now. So you then divide them, ln of 1 over 100, okay, ln of 1 over 10p, then divided by 2000, okay, then get 1.49. So t equal to 1.49. So you can put in here, so t is equal to 1.49 now. So calculate from here. T equal to 1.49 times 10 power minus 3 second, right? So actually 1.49 millisecond or 1.5 now, right? So it's 1.5. The time it reached is 1.5 millisecond. Okay, this is question 6. It's used a bit of application in the principle of electrical engineering to do this. So we write down the page number. Okay, so this is page 1. Okay, this is page 1. This is page 2. This is page 3. This is page 4. Okay, I don't want to squeeze too much here. So let me WhatsApp this to you. Question 6 here. So look at this one. Okay. You also stop the recording also.